The myth of geological time. One of the key battlegrounds for a creationist is the age of the Earth. There are 6,000 years of history, followed by the 1,000-year millennial period. We are nearly at the end of the 6,000 years, so there is not a lot of time to play with. The evolutionist thinks in terms of billions of years to provide time for evolution to take place. Geologists have attempted to tie in the geological age of the Earth with evolution, so they also require billions of years. I believe that the rock layers in the Earth are simply the result of the sediment sorting process that happened after the flood. Sorting describes how fine to coarse-grained sediments are distributed or settled, and how they will eventually lithify into sedimentary rock. Anyone can prove this process by taking some sediments such as clay, sand, silt, gravel, plant material, and general debris, shake it all up in water, and as it sinks, it will sort itself into distinct layers. All the layers of rock were in fact laid down at the same time. Many people will have seen tables of geological time, such as the one illustrated. Geologists have attempted to estimate the age of the Earth from the rates at which sediments are deposited. For example, saying that 1 foot of sediment is deposited every 2,000 years. They then attempt to establish the sequence in which rock layers were laid down, with the younger rocks being at the top and the older ones at the bottom. However, rock layers are in different orders in different places. Sometimes the younger layers are on top of older ones. So how was the rock sequence shown in the geological tables finally established? One way was to establish the age of the rock by radiometric dating and other unreliable tests. The other way was to determine which rock layer was older than another by studying the fossils of animals and plants within the layers. This method provides us with things called index fossils. Index fossils are any animals or plants preserved in a rock record of the Earth that are characteristic of a particular span of geologic time or environment. Fossils are assumed to have become more complex over time because of a belief in the theory of evolution. On that assumption, the presence of complex animal remains in a rock layer is said to show that it is of a more recent origin. Once the relative age of the fossils is decided, then that is used to demonstrate the course of evolution. This is a circular argument. The oldest rock layers are identified by the less complex fossils found in them, and so on, up to the complex fossils in the younger layers. The age of the fossils is then established by the rock layer in which it is found, which has already been classified according to the fossils found in it. Index fossils are normally fossils of extinct animals, of plants that are thought to have, or plants that are thought to have lived in a particular geological period. One problem with this is that many index fossils that were thought to be extinct are actually still alive. Not only that, but fossils of animals and plants that were thought to be extinct proved to be nearly identical to their modern counterparts. In other words, no evolution has taken place. In fact, the most common change is that the fossils of animals and plants are very often larger than their living descendants. There are literally hundreds of different types of animals and plants which are alive and well, and which are essentially unchanged from the way they appear as fossils. An example is the living Liquidambar styraciflua, if I've said that right. It grows in the eastern United States and is sometimes planted in Europe for its autumn foliage. The fossil liquidambar leaf is allegedly about 20 million years old on the evolutionist timescale. However, its leaves are almost identical to its fossil ancestor. The following chart gives more examples of living fossils. So we can see there's things called raptolites, which are small organisms that are index fossils for the Ordovician period, 300 million years old, but they're actually still living in the South Pacific. There's some reptiles called Tuatara reptiles that were supposedly extinct since the Cretaceous period, but they're still living in New Zealand. There's a conifer called the Metasequoia. As recently as 1945, these trees were thought to be an extinct species for the past 20 million years, leaving behind just a few fossilized imprints of their foliage as the only evidence that they ever existed. However, they are actually still alive in North America. You can actually see an example of this tree at Kew Gardens. Neopolina is a mollusk. They were well known as a fossil group from the Cambrian to the Devonian periods. They were thought to be long extinct until one of them was dragged up from the Pacific Ocean in 1952. Coelacanths are the famous fish. They were presumed to have gone extinct in the Cretaceous period over 65 million years ago, until one of them was fished up off the coast of South Africa in 1938. Another species of coelacanth was discovered in Indonesia in 1997, and a live specimen was caught a year later. There's some ants, Chrysalidrus ants, thought to be extinct for over 15 million years. It was only known by a single amber-fused fossil, and the species was considered extinct, as I've said, for over 15 million years. However, in 2006 it appeared throughout South America. And there's an animal called Chacoan peccary that was only known through fossil records and believed to be extinct. And then in 1975, a researcher found one alive in Paraguay. So there's many examples like this. But to sum up, rock layers are not proof of millions of years of time. They were formed very quickly. The fossils distributed in them were sorted into some sort of order as a result of sedimentation sorting. The quick formation of layers also happens as a result of volcanic activity and the laying down of volcanic ash, lava and debris. This was seen after the explosion of Mount St. Helens in America on June 12, 1980. An explosive eruption produced 25 foot of stratification that amazed geologists. Successive layers are traditionally thought to require long periods of time to form, yet upwards of 100 layers accumulated mostly between the nighttime hours of 9 o'clock and midnight. The quick sedimentation process is the reason we get polystrate fossils. These are fossils of a single organism, such as a tree, that extends through more than one geological layer. This has been a quick look at a complex subject, but the simple point to take from it is that many of the scientific things that we take for granted need to be questioned. The world is under the influence of a powerful deception that makes us doubt God's word. Science needs to be the servant of the Bible and not the other way around. If you found this video interesting, you can find more information at prophecy-workshop.com.